Lesson 114, graphing square root functions. Now, a square root function is just a function that contains the square root of a variable. So we'll just show you an example really quick. So example 1, y equals 3 times the square root of x minus 2. Now if we did a table of values, I'm going to pick numbers for x that have a perfect square. A perfect square root. So 0. The square root of 0 is 0. Times 3 is 0. Minus 2 is negative 2. When x is 1, the square root of 1 is 1. Times 3 is 3. Minus 2 is 1. When x is 4, take the square root of 4, which is 2, times 3 is 6, minus 2 is 4. And when x is 9, we take the square root of 9, which is 3, times 3 is 9, minus 2 is 7. And we'll do one more here, 16, square root of 16 is 4, times 3 is 12, minus 2 is 10. So when we graph these numbers, we have 0, negative 2, 1, 1. You know what? Maybe we should count by 2s on my... There we go. Whoops, if we count by 2s, then this one will be right here. Okay. Then 4 is going to be at 4. 1, 2, 3, 4, 4. 5, 6, 7, 8, 9, 10. So 9 is going to be at 7, 2, 4, 6, 8. So 9, 7. And it's going to look somewhat like this. It's going to keep going up, but getting slower there. There we go. That is called a square root function. Now if we look at this, we can say, well, our domain is x is greater than or equal to 0. Notice that there's no negative x's here. It just starts at 0. If you put in a negative x, you're not going to have any real values. This is going to be a square root of a negative number, which we can't have. And then the range is going to be y is greater than or equal to negative 2, because that's the lowest value for y, and then it just continues to get bigger. So that's the range. So here's example 2. If you're given a square root function, what would make the radicand 0 or negative? So here we have y equals the square root of x plus 9. So we want to know what would make this equal to 0 or negative. So x actually has to be greater than or equal to x plus 9. We can't, no, not x. Just a minute. X plus 9 has to be greater than or equal to 0, because you can have 0 under there and you can have positive numbers, but you can't have negatives. So if you take away the 9, x has to be greater than or equal to 9. That becomes our domain. So it's going to be all real numbers that are greater than or equal to negative 9. Okay, example 3. Let's find the domain of y equals 2 square root of x divided by 4 minus 9 plus 4. So what we need to do is we take x divided by 4 minus 9 and we set it greater than or equal to 0. We add 9 to both sides, so x divided by 4 has to be greater than or equal to 9, and then we times both sides by 4. So x has to be greater than or equal to 36, and that's our domain. Now we have shifts that we can do. So if we have the parent function and we have that's f of x equals the square root of x. That's our parent function. Now we can do a vertical shift if we add or subtract numbers on this parent function. So if we had y equals square root of x plus 2, this is going to have a vertical shift up 2 units. If we had y equals square root of x minus 3, this is going to go down 3 units. And then we can do horizontal shifts, and that's where you put a plus or minus inside the square root. So if we had x plus 2, this is going to take us left 2 units. And if we had f of x equals the square root of x minus 4, this is going to take us right 4 units. So it's kind of tricky. If you're adding or subtracting on the end, it goes up if it's positive, it goes down if it's negative. Inside the square root, if you see a plus sign, it's going to go left that many units. If you see a minus sign, it's going to go right. Now if you had a negative sign outside the square root, that's going to reflect in the x-axis. So it's going to flip upside down. And if you put a negative number on the inside of the square root, now all of your x's would have to be negative because you can't have a negative under the square root. So if you had a negative, that gives you a positive under the square root. And this is going to reflect in the y-axis. So it's going to flip over from side to side. So let's look at one example here. This is our example 4. We have graph y equals square root of negative x minus 5. So we can rewrite it as y equals the square root of negative x plus 5. So this negative sign, we know that it's going to reflect in the y-axis. It's going to flip over the y-axis. And then we see the plus, so we know it's going to go left 5 units. So we take our original parent function, we go left 5 units, and it's going to go there, and then it's going to flip over the y-axis. So instead of going this way, we're going to go, so this is the parent function. We'll just do it lighter. It looks like this. So we're going to flip it over, and then we're going to slide it to the left, so it's going to look like that. And that's the function graphed. So this is y equals square root of x. This is y equals square root of negative x minus 5. And that is the end of our lesson.